Welcome. In this video, we're continuing our discussion on quadratic equations. And today in this video, more specifically, we're going to review the different ways to solve a quadratic equation. Now, method 1 and method 5 here, that is the quadratic formula in method 1 and using technology in method 5 should be reviewed by now since we covered those in Unit 3, Activity 1. So let's look at example 1 in which we're going to review the quadratic formula. Solve 2x squared minus 3x plus 9 equals 18 using the quadratic formula. Well, first let's ask ourselves, is this in the correct form? If we look above, our quadratic has to be of the form ax squared plus bx plus c equals 0. Then we can apply this quadratic formula. We do not have a 0 here, so let's begin by subtracting 18 from both sides. And we end up with 2x squared minus 3x minus 9 equals 0. Now I can apply the quadratic formula. In this case, a equals 2, b equals negative 3, and c equals negative 9. So we have x equals negative, and b is also negative. That's why I added the parentheses here. Negative b plus or minus the square root of negative 3 squared minus 4 times 2 times negative 9. And this entire quantity divided by 2 times a, which is 2 in this case. This will simplify to 3 plus or minus the square root of 81 divided by 4, which is 3 plus minus the square root of 81 is 9, so that's where that comes from, divided by 4. From here we have two solutions. We have the positive solution, or the solution with the positive sign, and the solution with the negative sign. So for the solution with the positive sign, it's x equals 3 plus 9 divided by 4, and the other solution is 3 minus 9 divided by 4. And I want to add, this one will not always necessarily be positive, and this solution will not necessarily always be negative. So 3 plus 9 divided by 4 gives us 3, and 3 minus 9 divided by 4 gives us negative 6 over 4, which is negative 3 halves. So our two answers are x equals 3 and x equals negative 3 halves. Let's continue. Now that we've reviewed the quadratic formula, we're going to use factoring. And I'm going to show you two examples here. In this first example, we are still not in the correct form, so let's subtract by 8. We have x squared minus 5x minus 14 equals 0. Now this quadratic is of the form x squared plus bx plus c equals 0. So a equals 1 in this case, because if you recall, quadratics are of the form, well, when we're solving them, solving for x is ax squared plus bx plus c equals 0. But the coefficient here in front of the x is just 1. So this is the case where a equals 1. So this is a fairly straightforward case. We need to find two numbers. And the first number needs to multiply to negative 14. And the second number needs to add to negative 5. So as you can see, we're multiplying to c and adding to b. So what numbers multiply to negative 14? Well, a few of them, right? 1 times 14, where 1's negative, 1 times negative 14, negative 2 times 7, 2 times negative 7, and at that point we've exhausted all our possibilities. So now all we need to go through is check to see which of these add to negative 5. Negative 1 plus 14 is 13, so this is not it. One plus negative 14 is negative 13, so this is still not our correct answer. Negative 2 plus 7 is equal to 5, so we're getting close, but still we're not at negative 5. And now let's add 2 plus negative 7 equals negative 5, and finally, we are done. These are the two numbers we were looking for. That means this factors to x minus 14 excuse me, what am I doing? Our two numbers did not include 14. Our two numbers were 2 and negative 7. So this factors to x minus 7. X plus 2 equals 0. And then you can actually check your work. So if you want to check your work, go ahead and multiply this out again. So we start with x times x is x squared. X times 2 is 2x. Negative 7 times x is minus 7x, and negative 7 times 2 is minus 14. And now we can combine our like terms in the middle to get negative 5x. And of course the x squared and the negative 14 didn't change, and we're done. This matches this. So we know we've indeed correctly factored this. Now that we've checked our work, let's finish solving this since we are not done. And actually, I'm going to move this check right over there. So if two numbers multiply to 0, then I know that one of these numbers has to equal 0. So that tells me that x minus 7 equals 0 and x plus 2 equals 0. So if I add 7 to both sides, I end up with x equals 7. If I subtract 2 from both sides, I end up with x equals negative 2. So that means my two answers are x equals 7 and x equals negative 2. Let's continue. Next, we're going to solve 2x squared minus 9x minus 5, and I should have an equals 0 here, using factoring. This one looks a little different. In our previous example, our quadratic was of the form x squared plus bx plus c equals 0. Now I have ax squared plus bx plus c equals 0, where a is not equal to 1. So we're still going to find two numbers that multiply to something and add to something else, but we're going to do this a little differently. Now we want two numbers that multiply to the product of a times c. So that's 2 times negative 5 is negative 10. And we want them to add to this middle number here. So add to negative 9. So let's think of different ways to multiply to 10. We have negative 1 times 10. We have 1 times negative 10. We have negative 2 times 5 and 2 times negative 5. And now let's go ahead and add row by row. Negative 1 plus 10 equals 9. 1 plus negative 10 equals negative 9. Oh, I can stop right here. This is not correct. But as soon as I have found the two numbers that work, I can stop. What do we do from here? 2x squared minus 9x minus 5 equals 0. It would be incorrect, so this is incorrect, to write x plus 1, x minus 10. Why is that? Let's multiply this out. This gives me x squared minus 10x plus x minus 10, which is x squared minus 9x minus 10. This quadratic does not match this quadratic, which is why this is incorrect. So in the case where the a does not equal 0, so that is the leading coefficient is not equal to 1. Excuse me, I accidentally said 0 when I meant 1 just a second ago. In this case, we have to do some extra work. So let me go ahead and erase all of this so I can show you the extra work. And the extra work just comes in the form of splitting up the middle. So what do I mean when I say splitting up the middle? We'd all agree that 1 plus negative 10 equals negative 9. So I'm going to use that fact to rewrite negative 9 as the sum of x minus 10x. If I add x and negative 10x, I'll get negative 9x. So that's all I've done. I've just rewritten the middle term as a sum. This negative 5 has not changed, and this 2x squared has not changed, so I'm just going to add them in here. Now I can factor by grouping. And when I say grouping, I mean I'm going to factor this group, and then I'm going to factor separately this group. So this first group in orange has an x in common. 2x squared plus x, each have an x to spare, so I can factor out an x to be left with 2x plus 1. Now this second group, each term has a negative 5 in common, so I'm going to factor out that negative 5 to end up with 2x plus 1. And again, this is equal to 0, and this is equal to 0. If you notice, now we have a 2x plus 1 in each term. So x is multiplied by a 2x plus 1, and negative 5 is multiplied by 2x plus 1. That means I have 2x plus 1 in common in both cases, and I have x minus 5 left over, and that equals 0. Now that that's done, we can quickly set each term equal to 0. So 2x plus 1 equals 0, and x minus 5 equals 0. Let's solve. We subtract 1 from both sides to get 2x equals negative 1. Divide by 2 to get x equals negative 1/2. Now for x minus 5, we're going to add 5 to both sides to end up with x equals 5. So my solutions in this case are x equals negative 1/2 and x equals 5. And just really quickly, I move that over so that I can still check my work. I want to check that I factored this correctly. 2x plus 1 times x minus 5. Let's multiply this out. 2x times x is 2x squared. 2x times negative 5 is negative 10x. 1 times x is x. And then finally, positive 1 times negative 5 is negative 5. And this becomes 2x squared minus 9x minus 5, which is precisely what we have here. Well, that's it for this video. I hope this was helpful.